Hey everyone, this first video is going to review section 5.1 on systems of inequalities. So if you need more examples or extra support, look at the section 5.1 on our website. So the first thing you need to know about inequalities is what the inequality symbols represent. So whenever you see one of these symbols, you can notice that it kind of looks like an L. So these are our less than symbols. And also, our other symbol is this one. And this one is kind of, if you have a creative mind, kind of looks like a G. So this is our greater than symbols. Now you will notice that two of these have the lines underneath. This is the equal to symbol. So we have less than or equal to, greater than, and greater than or equal to. Those are the four symbols that you need to know. If it is less than, kind of makes sense that we would shade below the line. If it is greater than, then we would shade above the line. The other thing you need to know is that if it's equal to, you are going to draw a solid line. One thing that I remember is I'm like, well, there's a solid line. I should be drawing a solid line. But for these two that are not equal to, you are going to be doing a dashed line on your graph to note that it is not equal to. All right, let's do some sample problems to try this out. Now, the best way to rearrange your equations before you graph is to make sure that they are in y equals mx plus b format, which is slope-intercept form. That way you can see the y-intercept, which is the slope, the y-intercept, which is the y-intercept, the beginning point, and you can see the slope, which is your m value. That will tell you how many to go up and down, right or left. So, if you notice the first equation, it is not in this format. The 4x is on the wrong side of the equation. So, to get it to the other side, I'm just going to minus the 4x. And when I minus it, it will be a negative 4x on the other side of the equation, and I'm just going to bring down the plus 2. We cannot combine those two terms because x's and numbers are not the same thing, so we cannot combine them. So this is going to tell me that my first dot is going to be 2 because that's my y-intercept. So I go to the y-axis and I put my first dot at 2. Then I'm going to use my slope, which is negative 4. So that tells me that I'm going to go down 4, 1, 2, 3, 4, and run to the right 1. Anytime you have a whole number, there is an implied 1 underneath. And since it's rise over run, that tells me to go down 4, and we always run to the right. So that is where my line is going to go, and this pattern would continue on. Of course, I could go down another 1, 2, 3, 4, and right 1. I could keep doing that pattern, as well as I could do the pattern in the opposite direction. It's going to keep going that pattern in both directions. Next, I ask myself if I need a dashed or a solid line. Well, in this symbol here, it is not equal to, so I'm going to need a dashed line. Sorry, it is hard to draw on this thing. So I'm going to need a dashed line. And I also note that is a less than symbol. So that means I'm going to need to shade below the line. Now I'm just going to shade lightly as first because I don't know where my other line is going to be and I want to see where the shading is going to overlap. Okay, the second equation says y is greater than negative 2. So I'm going to go to the y-axis at negative 2, which is right here, and it says that I need a dashed line, so it's going to go straight across. This one doesn't have like a slope or anything. It's a zero slope line, actually. So I know that it's going straight across at y is equal to negative 2. It says that y is greater than, which means I'm going to need to shade above that line. So I noticed that the shading for both of them overlapped in only this corner right here. So this is my solution area. If it asks me for name a point that's in the solution, it could be any number that's in that green area. So, for example, I could say, let's see, 0, 0 would be a point. -1, 0, -2, 0, -3, 0, -1, 1, I believe is that point. Anywhere in here would count as a solution to this system. Now, because we have dotted lines here, if there was a point right on the line, this would not be considered a solution because it is not equal to at that point. If it was a solid line, then it would count, but it has to be a solid line in order for it to be included. So let's try another one in that sense. All right, so this one is already in y equals mx plus b format, so I'm going to graph it. The first line here has a y-intercept of -2, so I'm going to put my first dot at -2. My slope is 3, so that tells me to rise 3, run 1. We always run to the right. Up 3, over to run 1. I need a solid line because it is equal to, so there is my first graph. This graph also says y is less than, which means I need to shade below the line, which would be this side of the line. Okay, let's look at our second equation. Our second equation has a y-intercept of 6, so that's going to be my first point. My slope is -1. If there's no number there, I know it's a 1. So I'm going to go down 1, right 1, down 1, right 1, down 1, right 1. And I have a negative slope there. Since it is not equal to, I need a dashed line to go through those points. And it says y is greater than, so I'm going to shade above that line. So then you can note which area is shaded by both of these lines, which would be only this section right here. So none of this would be solutions, and none of this would be solutions. It would only be the yellow portion. So first it asks us, is 4, -2 a point? 4, -2. 4, -2 is right here, and that is not a point. It is outside of the solution area. So that one would be no. Well, how about 2, 4? 2, 4 is right here. I notice that it does fall on a solid line. However, it also falls on a dashed line. So that will not be a solution. Another way to verify that is to plug this point into your equations. So, for example, if I plug in 4 for y, I'm just going to do it in the second equation because it works actually in the first one. So if I plug in 4 for y, and then I'm going to plug in 2 for x, plus 6. So -2 plus 6 is 4. Is 4 greater than 4? Well, that is false. It's not greater than. It is equal to. And this is why this cannot be a solution, because whatever point you plug in, it has to work for both equations. The 0.24 only works for the first equation and not for both of them. Okay, let's continue testing our points. So how about 6, 2? Well, 6, 2 is right here, and it is clearly within the shaded region, so that one is yes. That would count as a solution to the system. -2, 8. -2, 8 is up here, and that one would be shaded by the second equation, but not by the first. So this one would be no, it does not fall in our shaded region. 8, 2. 8, 2 is right here, and yes, that clearly falls in my shaded region. That one would be yes. Okay, so now that we are good at graphing, let's go ahead and try a word problem. All right, so this number 16 says the girls' swim team is hosting a fundraiser. They would like to raise at least $500. They are selling candles for $5 and flower arrangements for $6. The girls estimate that at most they will sell 200 items. We are to write a system of inequalities to represent this situation. So we are just setting up the equations in this case. So whenever you're setting up equations, the first thing you need to do is figure out what it is you are trying to find. What are your variables going to represent? And you can use whichever letters for your variables that you would like to. So when we read this scenario, the two things that they're selling is candles and flower arrangements. And we don't know how many candles and flower arrangements they're selling. So we know that we're selling 200 items in all, but we don't know how many of those are candles and how many of those are flower arrangements. So we need to set those as our two variables. So we're going to have candles be represented by C, so we can remember that represents candles, and F is going to represent our flower arrangements. All right, so those are going to be our two variables. Whenever you have equations about money, scenarios about money, it's helpful to group everything together about putting all of your money together. So we have $5 for each candle that we sell. So if we take $5 and multiply it how many candles we sell, we know how much money we made in candles. I want to add that to how much we're spending in flowers. Well, if I'm spending $6 for each flower arrangement, I would multiply it times F, and they want to raise at least $500. So this whole equation, notice, is about the money. Put your money together. If they want to raise at least $500, that means they really would like to raise more than $500 if possible, but the minimum they want is $5. So we want a greater than or equal to symbol, so it's at least $500. All right, the other piece of information that we know is that they are going to sell at most 200 items. So the candles plus the number of flower arrangements they're going to sell, they expect it to be less than, if it's at the most 200 items, they're expecting it's going to be less than. And if it's at most 200 items, they're thinking it's possible for them to sell exactly 200 items. So we can put an equal to symbol under that. And this would work for our system of inequalities. We have now set it up to represent this scenario. So be sure you practice those word problems. Like I said on the notes, there's more examples like this for you to try, because these do take practice to set up, practice taking the words and transferring them into equations, because then later you could solve them if you needed to. Remember that doing math takes persistence and practice. So just know that you can do this. You've just got to practice, and I promise you will get it, and you will get better and better and better at math the more you practice. So thank you for watching this video and putting forth the effort to try to learn this material. You're on your way to being an awesome math student.